beats. Beats are also the phenomenon of outcome of the phenomenon of, you could say, superposition. Out of superposition, three possibilities arise: stationary wave, beats and interference. We are now trying to detail this process phenomenon of beats. Beats phenomenon is like interference, but it takes place only when the two waves have different frequencies. When the two waves superimpose with different frequencies, the resultant intensity changes with time. In interference process, that's complete name is interference in space, there we find the resultant intensity or the amplitude changes with the distance. But here in this case, when we are studying beat phenomenon, you must be aware that the resultant intensity will change with time. That means you don't change the place, you remain standing where you are, but the intensity will go on changing with time at that very place itself. And in interference, to notice the difference in intensity, you will have to move across, whether left or right or front or behind. But here you need not change the place, you will experience the fluctuation in the intensity. This phenomenon of fluctuation in intensity and superposition of two waves with time, this is called phenomenon of beats. The beat frequency means nothing but the number of times this fluctuation has occurred. That means in 1 second how many times it has become maximum or how many times it has become minimum, that is known as beat frequency. Beat frequency mathematically, when we go into detail of mathematical operations, ultimately we find that beat frequency comes out to be the absolute difference of the two frequencies. Here we need not be particular that will subtract it from N1 or N2, whoever is greater from that one, the other frequency has to be subtracted. This is the basic method of finding the beat frequency. In the process of studying beat frequency, one very important instrument that we come across is tuning fork. Tuning fork, you see, in this you are having two prongs, these are known as prongs, and this is known as stem. You see, if you heard this way, you heard this tuning fork, stem will be heard, stem which is vertical in itself, but this is going to be heard this way. Then longitudinal wave will start. Longitudinal waves have been produced in this stem, but when this stem will go upward, you see these four prongs will go little away from each other. That means when stem has gone upward, prongs have receded from each other. When stem this tries to restore its position, the prongs will again try to come back. That means the stem is oscillating vertically and the prongs are oscillating horizontally. It's very interesting in itself. You see, this is of unique nature, that in the same instrument you are having two oscillation. The stem is oscillating vertically and the tuning forks are oscillating horizontally. You could say both are oscillating perpendicular plane. Then if you are going to put some wax over the prongs, wax means you have made them heavier, obviously the frequency will decrease. In order to decrease the frequency of the tuning fork, one needs to put wax on the prongs. If you apply the process of filing or vaning also, sometimes the term used is vaning, W-A-N-I-N-G. That means to file, to rub this way, this is called filing. If prongs are filed, the frequency will increase. So, two things I have told you regarding this tuning fork. Actually, this is one very simple way of producing the frequency. The frequency that is produced here is known as standard frequency. Here we have the methods also to control the frequency. For increasing the frequency, method of filing is adopted, and for reducing the frequency, method of waxing is adopted. So, in tabular form we have just given the indication how the beat frequency could increase, decrease, or it can disappear. That too is given in this table. You see, tuning fork has its specific characteristics. It is considered to be one of the source of purest tone because overtones die out very soon due to high damping. When the weave is produced with the help of tuning fork, it's always going to be a pure tone. And moreover, the frequency that is produced is mostly of the order of 1000, little plus or little minus. Above all, when it comes to why this is so significant or relevant, the answer is simple, that it is used for finding the unknown frequency of some instruments.